Hi, in this video I'm going to talk about how do we find composite of two functions. Okay, so first of all we start from a function and then we'll find the value of the function f of x at different points or for different values of x, right? And then we will compose a function with another function later. Okay, so for the first example you can see that f of x is equals to 2x squared minus 1, right? So how do you find out f at 1? So you replace all x by 1, so it will be 2 times 1 squared minus 1, right? So how much is that? 2 times 1 squared is just 1, right? So 2 times 1 minus 1. So it is 2 times 1 is 2, minus 1 is just 1. Okay, how about f at negative 2? What does that mean? That means replace x by negative 2. So the right hand side, all the x's must be replaced by negative 2, right? So 2 times negative 2 squared and then minus 1. So how much is that? So 2 times, what is the negative 2 squared? It is positive 4, because negative 2 squared is negative 2 times negative 2, right? So that will be positive 4 and then minus 1. So it is 8 minus 1, right? So 7. How about f at a? Here it's similar to at 1 and negative 2. You replace x by a. What do you get? You get 2 and then a squared, right? You replace x by a and then minus 1. So what is a squared? It is a squared. So 2a squared minus 1. You cannot simplify it further. How about f at 2a? What does that mean? You replace x by 2a. Okay? X by 2a. So you get 2 times 2a squared and then minus 1. So what is 2 times, what is 2a whole square? Because whenever you simplify this type of expression, what you do is you first of all you should work with that parenthesis. Okay? So parenthesis square. So that means 2 times square root of 2a, that is 2a times 2a, right? So 2a times 2a is 4a squared. 2 times 4a squared minus 1. So what do you get? You got 8a squared minus 1. Make sense? Okay. Next thing is f at 3x. What does that mean? You replace all x by 3 times x. Okay, so basically you have 2 and then this x will be replaced by whatever you have here. So 3 times x squared minus 1. So how much is that? 2 times, what is 3x squared? 3x squared is 3x times 3x, that is 9x squared, right? 9x squared and then minus 1. So how much is that? 9 times 2 is 18, x squared minus 1. And finally, f at x squared, what does that mean? It means x should be replaced by x squared. Okay, so it will be 2 and then x is replaced by x squared. There is another square, right? And then minus 1. So x squared whole square means x squared times x squared, right? That will be 2 times x to the 4th minus 1. So basically 2x to the 4th minus 1. So this is what we did in the past, right? Finding the function at a particular value of x. Now, if the particular value of x is a function of x like this or this, then how do we handle that? We just replace that x by x squared. Similarly, we will take another example. We will define the composition of the two functions from this example. Okay, so suppose f is a function and then g is another function. So if you want to define composite of f and g, this is how we write that, f o g. And then instead of writing fx and then gx, it should be just f o g and then we write a single x there. And next thing is f composite g. This is how we read, f composite g. But for convenience, what we do is we read as like fog. Okay, so fog does not mean f times g. It is not the product. How do we define this? It is, you write f and instead of the o you write a parenthesis there and then gx. So gx, this is what you do. Okay, so the composite of f and g is denoted by fog or f composite g, and this means you write the first letter, first function, and then write the parenthesis. The second function or second letter go inside that parenthesis. Okay. Similarly, if you want to find g of f, you write g first, and then instead of that o, you write a parenthesis there, and then f of x. You write f of x there. Okay. So similar to these. So instead of f and then 3x, we have like f gx, right? F at gx. So how do you do that? So you just replace gx by 1 over x. What do you get? F at 1 over x, right? F of gx means f gx. You replace the value of gx as 1 over x. Now what does f do? F says that if there is x, you do 2x squared minus 3x. But instead of x, there is 1 over x. So x is replaced by 1 over x. So what do you do that? You do 2 times 1 over x whole square, right? And then minus 3 times 1 over x. So if you simplify that, what do you get? 2 times, what is the 1 over x squared? This is 1 over x squared, right? So 2 times 1 over x squared minus 3 times 1 over x. Or for simplicity, you can write like 2 over x squared minus 3 over x. You can write that way too, like 2 over x squared minus 3 over x. You can write that way too. This is also fine, or that is also fine. Okay, so let's take the second part of that. This is the composition of G and F. Composite of G and F. Okay, so to find out the composite of this, we follow exactly the same technique. So it is like you write the first letter or the first function G, and then write the parenthesis. For that O, write the parenthesis, and then fx. You write that way. Okay, so how do you find that? You write G. What is the value of fx? Is 2x squared minus 3x. 2x squared minus 3x. Okay, now, so if there is x in the function g, if there is x, then gx is 1 over x. We can describe this like input and output. X is the input and this is output. X is the input for x, f, and then this is output. Okay, so for g, if the input is x, then the output is 1 over the whatever input you had. So 1 over the input. But here the function g has input as 2x squared minus 3x. So what should be output? So it should be 1 over the input, right? So 2x squared minus 3x. That's it. So this is how we find the composition of the two functions. So let's take one more example on this. So in this example, f of x is given as 1 over x minus 2, and g of x is given as 3 over x. Okay, so you want to find f o g x and g o f x, meaning the composite of f and g, composite of g and f. Okay, also you need to find the domain of the composite function. Okay, so how do you find the domain of a composite function? To find out the domain of a composite function, what you do is, so to find the domain of fog, you need to find what values are not good for gx, meaning that what is the domain of gx, and you also take care of the domain of fog, like that. Okay, similarly for this one, you need to find what value is not good for fx, okay, and what value is not good for gofx, and you combine those two to find out the domain of gofx and also for fogx. Let's do this. Fogx, how do you find that? So you write f and then gx, right? So f and then gx. So basically the input is gx there. So how do you find that? So you replace gx by its value 3 over x. So f at 3 over x. So instead of x, we have 3 over x. So all the x on the right hand side of fx should be replaced by 3 over x. So it will be 1 over 3 over x minus 2. Okay, so how do you simplify this? There is a fraction in the denominator, right? There is 1 in the denominator. You write that into a single fraction. You combine that into a single fraction, right? How do you do that? Get the common denominator here. So what do you get? 1 over, so the common denominator of x and 1. So x and 1 is in the denominator. So you write the product of x and 1. X times 1 is x, just x, right? And then you multiply the cross, like 3 times 1 is 3, and then minus is in the middle, and then 2 times x, it is the cross multiplication there, twice x. Okay, so what do you get? So you got f at 3x, or basically you started from f of gx. F of gx, you got 1 over 3 minus 2x over x. This is the fraction of the fractions, right? So if you want to write this on the top, or if you want to write that in just a fraction, not the fraction of the fraction, what you do is you write the reciprocal of the bottom fraction, right? So you write 1 times x over 3 minus twice x, right? So what do you get? You got x over 3 minus twice x. So this is f o g, or the composite of f and g. Now you want to find out the domain of the composite function, okay? How do I find the domain of the composite function? So for that, you need to first find the domain of gx. What value of x is not good for g? X equals to 0 is not good for g, right? Because when you write x equals to 0, then you will get infinity. So the domain is equals to all real numbers except x 0. X equals to 0 is not good, that's why x not equals to 0. And another thing we'll look is what value of x is not good for the composite. So 3 minus 2x equals to 0. If you set that equals to 0, you will get 3 minus 2x equals to 0. So add 2x on both sides. What do you get? You get 3 equals to twice x. So x is 3/2, right? X equals to 3/2 is not good for the composite, because if you write x equals to 3/2, you'll get 0 on the bottom, right? And then you'll get f of g as infinity. So to find out the domain of composite function, what you do is you find the domain of the second letter. So here the second letter is g. You find the domain of g first. What value of g is not good? List that. And then after you find out the composite, what value of x is not good for the composite, you list that as well. That's the idea, okay? Let's do the second problem. Here, to find out the domain of this function, you should look at the domain of the second letter here, right? So f of x, okay, we'll see that. So g or fx is g and then fx, right? Because you write the first letter, and then instead of the small circle or the composite, you write a parenthesis there. Now what does g do? So first of all, let's plug in the value of f of x, g, and then f of x is 1 over x minus 2. All right. Now what does g do? So the input for g is 1 over x minus 2. But if there is x in g, then the output will be 3 over x. Whatever input you have, you divide that input. You divide 3 by that input, right? So here our input is 1 over x minus 2 for z, 1 over x minus 2. So what you do is 3 over 1 over x minus 2. Okay, so again there is a fraction of the fraction. If you want to write a single fraction for this, what you do is 3 times the reciprocal of the bottom. It is x minus 2 over 1. That's what you write. Okay, so what do you get? You got 3x minus 6. So there is 1 in the denominator, you don't have to write that, right? So 3 times x is 3x, and then 3 times negative 2 is negative 6. That's what you got. So what is the domain then? To find out the domain, what you see is, look at the second letter. So what is the domain of fx? Meaning that what value of x is not good for fx? That's right. So x equals to 2 is not good, right? Because you can set that equals to 0 and solve for x. So that 2 is not good. So how do you write that? X such that x not equals to 2. And what value of x is not good for this? So any value is good, right? So any x is okay. So that means just this is the domain. All the real numbers except 2 is the domain. Let us take a final example on the composite function. Here f of x is given as x squared minus 2x, and g of x is given as 1 over x minus 2. So you want to find f composite g at -1 and g composite f at 3. Okay, so how do we do that? So let me do the first. I will show this in 2 different ways. One way is easier than the other, okay, or the shorter than the other. So let's find out the easier way first. F O G. So it is f O g at -1. So this is same as f and instead of O you write a parenthesis and then G at -1, right? So what do? What is G at -1? Look at here. So G at -1 will be x replaced by -1, right? So 1 over x minus 2. So it will be 1 over -1 minus 2, right? So it is -3. So f -1/3, right? Because 1 over -3 is same as -1/3. Now, how do we find that f at -1/3? So f of x is x squared minus 2 times x, right? So you want to find f at -1/3. So replace x by -1/3. So you'll get -1/3 squared minus 2 times -1/3, right? So how much is that? It is 1/9. -1/3 times -1/3. Double negative is positive, and 1/3 times 1/3 is, there is like 1 times 1 on the top, 3 times 3 on the bottom. That is 1/9 minus and then -2 times -1/3 will be positive 2/3, right? Now you want to add these two fractions. How do you add that? So this has 3 on the bottom, this has 9 on the bottom. If you multiply and divide by 3 here, you will get 6 over 9, right? So this is like 6 over 9 plus 1 over 9 will be 7 over 9. That's how you find f composite G at a point. If x is given, then you just find out G at that point first and then plug in that into x for the function f of x, right? How about GOF3? GOF at x equals to 3. So what does that mean? This means G, right, and then f at 3. Okay, so what is f at 3? First of all, find out this value. F at 3, replace x by 3, you'll get 3 squared is 9 minus 2 times 3 is 6, right? So 9 minus 3 is, 9 minus 6 is just 3. So basically G at 3, because f at 3 is 3 squared minus 2 times 3, that is 9 minus 3, 9 minus 6, that is 3. That's the reason. So f3 is 3, that's why we want to find out G, and then f3 is replaced by that 3. So G3. So how do you find that G3? Replace x by 3 here. G3 will be 1 over 3 minus 2, that is 1 over 3 minus 2, right? So it is 1 over 1, that is basically 1. So GOF3 is just 1. So this is the shortcut method, okay? So I'll show you another method, the long method, but I'll do only for FOG at -1, okay? So to find out FOG or GOF at a point, so what you do is you find out FOG at x, as we did before, and then you find out this value, and then replace x by that -1 later, okay? That's the idea. So this is same as f and then gx, right? So what is f? Sorry, what is gx? Gx is 1 over x minus 2. That's the gx, okay? Now you want to find out f at 1 over x minus 2. So replace x by 1 over x minus 2. You'll get 1 over x minus 2 whole squared, and then minus 2 times 1 over x minus 2. That's what you got. So this is that function. You can simplify it or you can leave it like this, but you want to find out at -1. So FOG at -1 is replace all x by -1. What do you get? You get 1 over -1 minus 2 whole squared minus 2 times 1 over -1 minus 2, like this, right? So what do you get? 1 squared is 1, -1 minus 2 is -3 squared. -3 squared is 9, right? Positive 9 minus 2 times 1 over -1 minus 2 is -3, right? So it is again 1/9 minus a plus 2/3. So 1/9 plus 2/3, we got it 7/9. 7/9. So you can follow either way, but this is shorter than this method, okay? So if it is asked like this, you can follow the easier and shorter method. Thank you guys.